Hi everyone, today I will share the knowledge of USB 2.0 signal quality testing. I will start by introducing the basics of the USB protocol, USB 2.0 physical layer compliance testing, and how to use Rigol DS70000 to conduct USB 2.0 signal quality testing. Since the USBIF organization released the USB 1.0 standard in 1996, the USB standard has evolved through several versions, including USB 1.0, 1.1, 2.0, 3.0, 3.1, and USB 3.2. In 2019, the USBIF organization released the latest USB 4 standard, bringing a new standard specification to the USB interface. The final name is as follows: USB 1.0, 1.1, and 2.0 are known as USB 2.0 low speed, full speed, high speed, respectively. The USB 3.0, USB 3.1, and USB 3.2 are known as USB 3.2 Gen 1, Gen 2, Gen 2 by 2, respectively. The transmission speed has also been gradually increased from 1.5 megabytes to 40 gigabytes, from low-speed devices such as mice and keyboards to universal multipurpose interfaces. In this development, the USB interface, the encoding, the classic wire length, and the logo were also changing. In order to ensure compliance and consistency with USB interface products, all companies seeking to use the USBIF logo on their products must file a valid USBIF trademark license agreement on USBIF, and the products must be certified. USB 2.0 uses a 4-wire system. V-bus, D+, D-, and GND. D+ and D- are differential signal pairs that act as the primary carriers of communication between hosts, hubs, and devices. USB 2.0 replaced and consolidated the USB 1.1 specifications that defined low-speed and full-speed data transfer, and it introduced high-speed data transfer. USB 2.0 is backward compatible with USB 1.1 and 1.0 and has 3 speed modes as shown in the table below. Low speed 1.5 megabytes, full speed 12 megabytes, high speed 480 megabytes. There are also some differences in the definition of state under different standards for signaling of USB 2.0. Next, let us discuss the content of the USB 2.0 physical layer compliance testing. In 1994, Intel and Microsoft collaborated with Compaq, DEC, IBM, NEC, and Nortel developed the USB transport protocol. The latter two companies established a non-profit organization in 1995 to promote and support USB called the USB Implementers Forum. This organization primarily aims to promote the development and application of USB technology by proposing a series of related regulations. For example, USB products that pass USBIF certification are allowed to use the corresponding logo, and certified products are guaranteed to be compatible, etc. So which companies need to use the consistency test for the USBIF physical layer? First group is personal or business computer companies such as Lenovo, Shenzhou, HP, etc. Second group of companies is memory such as a USB stick. Also, the manufacturer of the USB chip needs to perform consistency testing. Products that use USB chips for development also undergo conformity development and debugging to ensure reliability. Conformance testing is a set of rules defined to ensure that various USB products are compatible with each other. It is good to avoid embarrassing situations like the USB of the computer can recognize the mouse but cannot recognize the disk. The tests for USB include signal quality, inrush current, fall and fade, packet parameters, timing test, receiver sensitivity. Consistency is primarily a test of signal quality. The signal quality test can be divided into 10 test items such as eye diagram test and signal rate. However, eye diagram testing and monotonicity testing are not conducted for low speed and full speed, whereas high speed does not undergo cross-point voltage range testing. The results of the eye diagram test of the USB 2.0 signal need to conform to the standard eye diagram template provided by the USBIF Association. In the USB 2.0 homogeneity test, the eye diagram test results are an important reference item. Can see that the near end of the eye diagram test template for eye diagram more stringent requirements. The signal rate of USB 2.0 is not as high as it can be and must be within the required speed range to pass the test. For the USB protocol, All packets end with an end-of-packet field. The width of the EOP field is defined in bit times. For the end of packet of the start of frame packet, it is required to be between 39.5 bits and 40.5 bits. For the end of packet of non-start of frame packets, it is required to be between 7.5 bits and 8.5 bits. The cross-point voltage range is only required for low and full speed between 1.3 voltage to 2 voltage. The USB 2.0 high-speed jitter test results are included in the results of the eye diagram test. Jitter includes continuous jitter, JK pairing jitter, and KJ pairing jitter. The main project and standard for high-speed jitter testing is that all three types of jitters are in the positive and negative 100 ps range. For low and full speed signals, the rise and fall times refer to the time required to rise from 10% to 90% of the signal amplitude, as shown in Figure 3, which applies to the conversion of differential signals and between differential and single-ended signals. For high-speed signal, edge rise, lowering time is greater than or equal to 500 ps. Rise, the rate of decline is less than or equal to 1600 volts per microsecond. High-speed data conversion requires monotony at the minimum vertical opening specified in the eye template. So in the USB 2.0 high-speed consistency test, developers need to verify the monotonicity of the signal being measured. The monotonic verification sends a signal amplitude that should be raised or decreased smoothly without any opposite direction deviation. You can pause the video to learn more about the other USB 2.0 compliance tests. Next, let's introduce how to use the DS70000 for USB compliance testing. USB-IF in the USB 2.0 standard has a clear definition of the content and specification of each test item, and a manual test method is given. However, manual test configuration, validation, and summary results reporting increases repetitive effort and reduces efficiency. The Rigol USB 2.0 conformance testing software automates the testing process, allowing engineers to conduct conformance testing efficiently and accurately. Preparation for testing according to the association's request, our recommendation for oscilloscope and probe bandwidth is above 2.5 GHz, so we chose the Rigol DS70304 with 3 GHz bandwidth and the PVA 8350 with 3.5 GHz bandwidth differential probe. In addition, we need USB test fixtures and computers with test software. Let us start with host testing. In the environmental construction part, we first connect the probe to the oscilloscope and calibrate it, then plug the clamp into the USB port of the computer. Next, select host type in the test software, select test packet in port control, and select the corresponding port number to click execute. The probe captures the signal on the fixture, opens the USB consistency test analysis software on the oscilloscope, selects the probe's channel and test content, and then click Start Test. When the test is complete, there will be data displayed on the oscilloscope and an indication of the passing of each test indicator. We can save the report as PDF or HTML. Testing of the device is slightly different in terms of building and testing software. First, we need to put the device on the fixture, then connect the control port of the computer and the probe. The test software selects device, and the port needs to be selected before the port control is selected. Subsequent processes are consistent with host operations, capturing waveforms, analyzing and exporting reports in the same way. One last thing to add, USB testing is divided into two scenarios: near-end and far-end testing. Near-end refers to testing at the peripheral device socket before or without signal transmission through the cable, such as USB flash drives and computer USB ports. Far-end refers to testing at the end of the specified cable or with connected peripherals like mice and keyboards that have cables attached, using the far end for testing. The main difference between the two lies in the different eye diagram templates, with higher requirements for the near-end template. The conclusion is USB 2.0 interface with higher transfer speed, support for hot plug and multiple device connection characteristics, can meet users' need for ease of use has become the final choice of most external device manufacturers. However, the rapid rise in standards and capability also presents equipment designers with modern design challenges that must be addressed. Rigol provides a complete set of tools, including digital oscilloscopes, professional test fixtures and probes, and fully automated consistency testing software, enabling USB 2.0 device designers to capture, test, and analyze signals efficiently and accurately.